Hello viewers, my name is Gadi Ornan Ruiz, a student of MT Block 3C. I will be performing a video simulation on total RNA extraction using the solid phase extraction method. This is a sample preparation method that uses positively charged silica membrane to filter out unwanted molecules and bind negatively charged nucleic acids under high salt concentrations that can be filtered out separately to yield pure nucleic acid. This involves 4 basic steps: lysis, binding, washing, and elution. To demonstrate this, I will be using alternative household materials. For my sample, I will be using Listerine mouthwash contained in a micropipette container in order to represent a colored solution, while for my buffers, I used distilled water contained in evacuated tubes. These plastic cups will be my collection tubes, spinner column, and extracted RNA tube, while these short plastic containers for my ethanol and buffers. These medicine droppers will be my pipettes. For my centrifuge, I will be using my mom's salad rotator or spinner, while this vibrator, or should I say electronic massager, will be my pulse vortex. And lastly, this mini trash can as the discard container. Now let us proceed to the simulation proper. First, we must pipette 560 microliters of prepared buffer AVL containing carrier RNA into a 1.5 ml microcentrifuge tube. Next, we add 140 microliters of our sample to the 560 microliters of buffer AVL carrier RNA in the microcentrifuge tube. Then, we mix by pulse vortexing for 15 seconds. Incubate at room temperature for 10 minutes. This will allow further lysis of viral RNA. Briefly centrifuge the tube to remove drops from the inside of the lid. Add 560 microliters of ethanol to the sample and mix by pulse vortexing for 15 seconds. After mixing, briefly centrifuge the tube to remove drops from inside the lid. This will now be our lysate. Now let us move on to the second step of RNA extraction, which involves binding. This can be done by carefully applying 630 microliters of the solution which contains our lysate to the spin column without wetting the rim. Centrifuge at 8000 rpm for 1 minute. Place the spin column into a clean 2 ml collection tube and discard the tube containing the filtrate. Now let us move on to the third step, which involves washing. This can be done by carefully opening the spin column and add 500 microliters of buffer AW1. Then we centrifuge at 8000 rpm for 1 minute. Place the spin column in a clean 2 ml collection tube and discard the tube containing the filtrate. For the next washing procedure, we carefully open the spin column and add 500 microliters of our buffer AW2. Then we centrifuge at full speed of 14,000 rpm for 3 minutes. Place the spin column in a new 2 ml collection tube and discard the old collection tube with the filtrate. Then centrifuge at full speed for 1 minute. Place the spin column in a clean 1.5 ml microcentrifuge tube. Discard the old collection tube containing the filtrate. Carefully open the spin column and add 60 microliters of buffer ABE, equilibrated to room temperature. Close the cap and incubate at room temperature for 1 minute. Centrifuge at 8000 rpm for 1 minute. Discard the spin column and close the cap of the tube. Tan-ta-da-na! Now we have our pure viral nucleic acid. Viral RNA is stable up to 1 year when stored at -30 to -15 degrees Celsius or at -90 to -65 degrees Celsius. That ends my total RNA extraction video simulation. I hope you enjoyed and learned something from my performance. Thank you so much for watching and God bless.